Hi team. In this video, I want to provide some basic properties and formulas for differentiation and work through some examples. Let's get started. Computing the derivative of a function using the definition of the derivative can be time-consuming. Consider the function f of x being equal to x divided by x plus 1. Working out its derivative would take a fair bit of time. Fortunately, there are a number of useful properties and formulas we can use. Some basic properties and formulas are listed here. Okay, so one of the formulas for differentiation says that if you have a constant, let's say f of x being equal to c, that the derivative of this is going to be 0, so that f dash x is equal to 0. So let's use the definition of the derivative to prove that this is true. So we know that the definition of the derivative is given as f dash x is equal to the limit h to 0, f of x plus h minus f of x all divided by h. So we can take this f of x being equal to c and substitute into this formula here. So because there's no x component here, there's no substitution of the plus h part. So really this just becomes c minus c over h. So c minus c all divided by h. So c minus c, 0. So even though we haven't substituted in for this limit of h tending towards 0, the fact that c minus c is 0, well, that just tells us that the derivative is in fact going to be 0. Okay, let's look at an example. Let's say we have f of x being equal to x squared. And we want to figure out what the derivative of this function is. Well, we know that for f of x being equal to x raised to the power n, the derivative of this function is given by this formula, nx n minus 1. So let's use this to figure out what the derivative of x squared is. So we know that f of x is x squared, so we can write f dash x is equal to 2x1, which is equal to 2x. That's our derivative. Now we can check this using the definition of our derivative. So we know that f dash x is equal to, taking the limit of h to 0, f x plus h minus f of x all divided by h. So we can substitute into this formula for x squared. So we end up having x plus h squared minus x squared all divided by h. And so this expands out to being equal to, so we've got x squared plus 2xh plus h squared minus x squared all divided by h. So the x squared terms kind of cancel out, and we can divide by h. So what should be left is 2x plus h. So we can write that. So for the limit of h to 0, 2x plus h. So taking the limit to 0, so this h term becomes 0 and we're left with 2x. So using the definition of the derivative, we've come up with the same solution as to what this formula here gives us. In this video, I've introduced some basic properties and formulas for differentiation and worked through some examples. I hope you found it helpful. Thanks for watching.